Hello everyone, welcome back to my channel. I hope you're doing extremely well. So yesterday, like in my previous video, we have learned about the unique path, how can we find in a grid or in a 2D matrix, and we have solved that question through a recursion approach as well as DP with the memorization approach, right? So we have learned till now. This is the part 2 video. First of all, till now we have learned how can we solve through recursion and what is the problem from this approach, that the time complexity is 2 power n, which is very high, okay, exponential time complexity. And now after that we have learned how can we apply precision technique means in a DP, and this has been solved with order of n time complexity, right? And now in the today video we will uh, do very important thing, that we can firstly we will solve it through tabulation technique. After that we will learn how can we optimize the space complexity. Yes, as you are right, how can we optimize space complexity from order of m cross n to a constant space. So let's start. So how can we optimize, how can we, what is the tabulation and how can we do it, right? How to convert from memorization to tabulation. And the one that helps us to from memorization to tabulation is that it reduces the state space, because we don't have to use recursion, so in that the space will be optimized a little bit. So let's take an example. Let's see, this is the DP, this is the grid that is given, and there is 3 cross 3 grid is there, right? Means 3 rows 3 column, and from here we have to reach to this point, right? So how can we do it? Let's, what we will do simply, if we will simply create one 2D DP array, okay, and we will start from the bottom, right? Let's assume this is the only one cell. Then what would be the answer? 1. So I will simply initialize the 1. And if this is only one row, then what would be the answer? Definitely the answer would be 1, only 1. Or if there would be only one column, then what would be the answer? There would be 1, right? So we initialize the first last row and the last column, right? After that we came here. We will simply add these 2, right? Now what is the value after adding? The value is 2. Add this 2. We came here. We will add simply these 2. That is nothing but 3. Now we came here. We simply add this 2. What is the value? 3. Now we came here. We simply add this 2. That is 6. 6 is our answer. I am sure that this tabulation is clear. Let's try to write down the pseudocode for this tabulation approach. So we have created one DP, right? Let's write down function. Yeah, that is passing m n. So what we will do simply, we will create one DP, and simply what we will do, we will simply write down the new int dpm cross n, right? And so initially we initialize dpm minus 1 and n minus 1 with 1, right? So the main concept to conversion from memorization to tabulation is that whatever the base case, the base case, simply write down that initialize it before, right? After that what we'll do, we'll loop. As we have seen there are 2 times we are calling. Firstly for increasing a column, or second time we increasing by a row, right? So we'll do the same thing, that we will do a row that will start from m minus 1, and rows will definitely rows till 0 and row plus row minus minus. After that column and column is what, like starts from n minus 1 and it goes till 0 and column minus minus. Simply I will check the base case that if either row equal to what uh, last m minus 1 or column equal to n minus 1. In the both the cases, simply write down this thing. Slide with 1, right? Otherwise, simply add. Uh, Here I have done one mistake. So here I have to write down that dp row and column equal to 1, right? Then what I will do, simply here write down dp, just add row column equal to, add its next, means its right cell plus dp wait. That's it. And at the end, simply I will return dp 0 0, right? This is all about. So I hope this video helps you a lot, and this is about tabulation. Let's come to the code editor, and I can easily convert it here to from the memorization to tabulation. Already I have been declared on dp, so simply I will write down row equal to m minus 1, row greater than or equal to 0, row minus minus, for integer column equal to n minus 1, column greater than or equal to 0, column minus minus, dp row column. So I will check that base case. If this is last row or last column, so if row equal to m minus 1 or equal to n minus 1, so in that case basically what I am doing, basically do dp row column to 1, right? It's clear. And that's all about this. And after that, yeah, if it is not, so simply I will do the same thing, right? This is what I will do. Basically this is what I am going to do. Write this one, this I will copy as it is, and instead of this what I will do, simply I will write down this C here. This is the current column plus 1, right? Same thing I will do here, a dp row as it is, but instead of column I will do column plus 1, right? Same I will do here as well. I will call dp and at the row plus 1 and column will be as it is, right? This is, and yeah, and instead of return, what I will do, I will simply a row and column, right? Yeah, that's it. And what I will do, simply add this I will call DP 0 and 0, right? So this is all about. Let's try to run this code, and definitely I'm sure it will work. Yeah, it's work perfectly fine. And if I'll submit the code, so it will definitely work. Yeah, it's work perfectly fine. Now we know and we learn how can we convert from memorization to tabulation technique. Let's try to run how can we optimize the space complexity from order of m cross n from 2D matrix to constant, right? How? Let's see carefully here with this example, right? Let's try to take another example here. So we are at here, right? The answer is 1, right? If we are at here, so we only care about this value and this value. If we are at here, so only care about this value, right? And this is not possible, so this only this value. If we are at here, then we only need this value and this value, right? Clear? If we are at this place, only need this value and this value. And from where this value will get, this value will get from this value, right? So if we know this value and this value, then we don't care about other value. So if we just need two value of any cell, so why do we need to take care of all the matrix? Why we need to store all the entire matrix? We just take take 2 pointer, right? And we will do our rest of the work. So what? How can we do? Let's see with an example. Let's try to clear it up. Let's 0 1 2 0 1 2, right? And see here, what can I do over here? See that. So firstly I will take one, let's simply the DP 1D DP that is initialized with number of column new int n, right? Now what I am basically doing here, for basically row, I will run rows till n m minus 1 to 0, and here basically I will take another temp DP that is for current storation, okay? Equal to new int n, right? After that, what is happening here, or basically we are writing here for, I will execute the loop for column equal to basically n minus 1, right, to 0, and what is happening basically here, column n minus 1 for column n minus 1 to 0. Yeah, and now what is happening here? Yeah, so basically what I'm doing here, we basically check if we'll do the same thing, if or is it last row or column, is it last column, if either any of the cases true, so I'll simply write down this temp, okay, and column equal to 1, right? If this is not the case, simply I will write down, I will simply add. What I'm going to add here, basically add the current temp, current column, add equal to temp, current column plus 1 plus DP column, right? And at this loop, I will simply swap that temp will be sliced to the DP. And this is all about. At the end, I will simply return DP 0. This is our answer. So guys, let's come to the code editor and try to write down the code. Okay. So to save the time, I have already written down the code here as well. So instead of 2D DP, I will simply write a 1D DP. For integer row equal to minus 1, and I'll write down the same. Okay, I will use this one, 0 row minus minus for integer column equal to n minus 1 column greater than or equal to 0 column minus minus, yeah, dp to that of check basically if row m minus 1 or column equal to n minus 1, then simply uh, dp column is equal to 1, that's it as it is. I have to write down the temp. If it is not true, then it means that we are at that cell where we can move right or down. So in that case, temp column equal to temp column plus 1 plus dp column, right, as it is. That's it, and at the end of this loop I will simply return dp0. So this is the all about. Let's start run this code, and let me check if it is work perfectly fine. Yeah, it's work perfectly fine, and now we have know how can you optimize this space. But see, here one is also trick, that as we are using 2D, two like a 2 array, right? One is here, one is here. So when we are at here, let's see that we declare that we declare like 0 1 2 column, right? And at all the below at the last row will be initialized with 1 1 1, right? It's clear to you? Yes. So what is that? What is that? That we are at here, right? We are at here. So if we are at here, then definitely the value will be 1. But if we are at here, so we need this value and this value. So from where if I'm at the 1th place, so I can take this value which is 1, I know. And for the bottom value, I know already 1 is there. This is 1. So I will reuse that. And after using, I will replace it with the 2, right? When I'm at here, this is 2. When I'm at here, at the 0th column, right? So this right side is 2 that I'm getting here. But the below value is 1. Plus 2 is 3. Okay, let's come to the 0th row. We're at here. Simply I will write down that this cell value 1. It's clear. Now we are at here. So we take this value which I am getting from here, and I will take this which is below value. It's 2, but we know 2 is here, same. So we use that value at 3. So I will update this one, that is 3. And I came here. I know this value is 3 and this value is getting 3. So 3 plus 3 is 6. I'll update this 6. Clear? So we don't need to use that extra temp array. So definitely I will remove this one. And instead of temp, I will use dp, and here as well, so dp, and basically here. So if I'll try to submit, write down this thing, dp, right? Yeah, it's worked perfectly fine. And this is the most optimized solution for this question. I'm sure this video will help you a lot to understand the concept. And if you have watched till the last, so please like this video, and thank you so much for watching the video.